Hello, everybody. So I'm continuing with the uh, tutorial. It's maybe the wrong word, the work tutorial. I'm astronomer from Helsinki, Maria Stone. Thank you for joining me today. I also have several books that I have published, poetry and my other nonfiction testimonies, so kind of book, exploring Helsinki book, a little bit about my journey as a scientist, or grumblings, let's say. They're all on Amazon, including an ebook format. So it's quite closer today at home because I have to I want to finish it because we're going on a vacation afterwards. Um, so I'll start by sharing my screen. And also, so today I'm doing video tutorial part 13, which is 1D spectrum extraction. Thank you God so much for helping us with this project. Um, and the aim is of this project, this is not like a clean tutorial, step A, step B, step C. This is just really working on myself and I'm putting it online, like an open client. So the hope or the aim is to really demystify science project work. And of course, you can see how I'm thinking, how I'm working, how I solve problems. You know, of course, it can be later polished into a tutorial, but there are so many spectroscopy reduction tutorials that I feel like it's redundant. What did we do last time? We performed background subtraction. I was having a problem because what was the problem? Something wrong with the x coordinate. They were not. There was basically a discrepancy between the DS9 and the IRA. So when I plotted in DS9, it would show coordinate x20, but in IRA, x40, so 2 times more. So where is this factor of 2 coming from? What's going on? And I reviewed the steps all the way to the beginning of this procedure. Even the overscan. I looked at the beating, I looked at the header. I could not find what was the problem. So at the end, I just quit IRAP and DS9 and I reloaded them. And after that, when I opened the same files, then the X coordinates were inaccurate. Uh, and it is important for this step. And also, I was, trying to show it to the public, so it has to be correct. Uh, so there is a tip. If something is going wrong, one method is one solution could be to close everything, to close IMAP, close the S9 and restart it. Just remember to load the correct packages depending on which step you are at. So now, recording. Now I actually okay. Um, be patient with the kids' noise. It's the evening right now here, and they deserve to just be themselves. I don't want to ask them to be quiet. That's their home. So we are going to take this 2D image of the spectrum, the 2D spectrum, and extract 1D. First, we're gonna determine the center. So I'm gonna stop sharing here. I'm gonna start sharing. Um, the other computer. There are two methods to do it. You can, for example, use a pixel table. And what it does, you go to this slide, analysis, pixel table, uh, and You can hover over. The axes are x and y coordinate, rows and columns. And then here is the value, within each pixel, how bright it is. And I want to pick the one that is within this emission line, the highest. So I see some values. 208 to be the highest, and it is x equals to 40, column number 40. Then let's try another emission line here. It looks like again, the peak value is in column number 40. It is 194. We can try this guy also, or other. When there's an emission line, it's kind of easier. 170, column number 39. No, there's 173. Column number 40. So I can write that in my research notes that for spectrum A, the pixel table showed that column 40 is the peak, but you could also do through ion plot. So I am plotted here the background subtracted spectrum A of quasar 121. And then I plotted the lines 1240 to 1270, which straddles the emission line of bright emission line. And then I can come with the crosshairs right here, where the peak is, and I can already see that it is 40, but you can click, let me click somewhere else. You can click spacebar, and with the spacebar, this ion plot. This one's I'm plot, click space bar, it gets a coordinate value. So here I click place bar and it is the pixel 40, 1240, the value is 140. Yeah. So this is my peak. You can see the table. Is that plot spacer? Also peak is x equals to 40. And then now I need to figure out how many column go there. Okay, so actually I'm using this way of doing things for the first time, but so da baby. So maybe from here, which is number 17 to here, to 63, 17 to 63. 3 minus 17. We extract. That is 46 lines. 46 columns, I should say. Mama, Okay, so we determine the let's say for simplicity that this is 40 and on each side there's 20 columns, so total 40. Please, Natalie, we'll do 41. Am I saying it right? So now to do as copy, I have to specify, and I'm just looking at the documentation. I'll quit the I am plot. Just one format should be output. The format. Output image format names as the best format is a one or more the same image files a one display box per image with names having a root name and a 4-digit aperture number extension. So I need one spec. Renumber no. Mama. Hold on, Natalie. Yeah. So like I said, it's my first one, so you have to use and some specify task and some is not found. Where is and some?
You want them? You want it?
Wait, I want this. And also, no. Task and sum is 41. 40. And some not found. The packages are loaded and then so but then z and sum equals to and some works here. Like yes. So 1.1 8 our input is so 121 a dot b and then our output is q so 121 a on d. And we want the aperture list of input apertures or column. Column 40. We want the spec. 60. Okay. Go. I'm gonna copy this into here.
No, it's the other side. It's this one.
Load to the spec mostly package, then mostly to run. Present this, and then go. Fit like fix. Execute. Like that. use
write something down.
explode. This is our spectrum. There's the emission line. So, we can take a picture. This is our body spectrum, and then we can do music, box size, for example, 5.
One. Two. Yes. Fox.
Maria, I want to like my pen. Like, take here. It's like that's like
Put it here.
I can the file. Like you want that. Here we go. Wait,
It says if I press on, image to create QSO, what 21, A, what B, lose, and then we do the same thing. We're recording.
Like
Oh,
here.
here is some color lines 1780 to 1830.
I like it.
Our peak is 33. Yours peak 33. And then
Mine?
we will sum 16 to 36.
One.
Now we say at the side equals 2 35 and all the way back.
On the butterfly. Oh, what that? Butterfly. Okay.
Okay,
No, it's like this
and
one.
then we part as
I can see. Like
because I want to do my thing.
here and like
Picture was
this.
33.
No.
I said it's so close. 35.
Yeah.
Yes.
Maybe we can play something and do some this one. Archie, we need not one.
See everything.
B. Anna Maria. Anna Maria. What your name?
Yes, Anna Marie.
Anna Maria. Anna Maria.
Think we're done.
Maria.
Oh yeah.
That's also.
Wow.
Maria.
What is
You can say it if you want to.
You had to alternate like Anna Maria. Anna Maria.
No.
our spectrum?
Anna Marie. Only.
And we do as
Name numbers. I tell you something. Numbers.
Yes.
And we have banana. And
7. No.
and then I suppose it was 5.
7. No. No. No.
The light here.
Almost.
Uh,
It's nothing. 7 is here.
that I
5 and 7
Yes.
and 1.
saved it. Take a picture.
Yes. How about 4?
2.
All right.
Yes.
It happened 4.
And 10?
I can compare it with my test because in the test I didn't do
Yes. Yes. No.
in my test I didn't cut individually the strips. I just did background subtraction on the whole thing. I cut I trimmed just the edges a little bit and then I used the central strongest lines. Where's my
No.
okay.
Like this.
This is my new guy.
Yeah, you can read that.
This is my other which should be placed.
Mama, yeah, farting one.
Nada. Ask Anna Maria. Sorry, I'm busy right now.
That's funny one, but I want this one.
So you can go to window, buffer, and then when you have two of them open, you can blink them. I put 800 milliseconds. You
My
Which one?
one there.
This one.
Yes. Okay.
you want there's an absorption line that comes through because in the old one, what if I open also?
What about more?
Hmm,
That or that?
Star. Yes. In the other side. The other side.
Yes.
Yeah.
In this
Side.
case,
This
this
is-
is 1D spectrum.
Is
This
this?
is boost one. We still need
No,
to
it's
do
okay.
a few things. In the procedure, I will close this and share my other.
Was also different kind of.
This highlights are you have to look like otter.
Yeah, I have other one also.
Twister.
I have green one and then
Uh,
heart and
And also Nathan.
so we did
yeah.
finish this 1D. And we can update my tutorial. Next step is standard star flux calibration. This is standard star, but okay, we did this. This S-copy.
And this is pink. And this is the mark.
I'll say follows the log. This is the first object which we did. We took screenshots. I'll update the file. Is everything that can be written to the paper at this point? Yes, the IRAF acknowledgement. I realized I did it.
Yeah.
And that.
Oh.
So yeah. Sorry, my time is ending, so.
Oh, you tried running early today.
Yeah.
Yeah, thank you.
Thank you so much.
Hey guys. Oh,
I'm saying bye. I'm
say
leaving.
goodbye.
Bye bye.
Bye bye.
Bye bye.
I'm leaving.
Oi, oi, oi. Let's say something nice. How about Anamari John?
No.
Anamari John.
Wait, I'm gonna use my own.
John means sweetheart in Armenian, like a nice face. Yes, you might very well, I would appreciate it. Yeah, and that's about the calendar. That's what I do.
Yeah. 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 This is so bad over.
Like the winter this winter too. It's
Yeah.
like I'll be winter last winter. Or when the winter's like that sometimes.
Yeah. Then we might do.
Yeah, for sure. Okay, yeah, bye.
James, I'm still recording something. I need a bit. Huh? Okay. What is there? Resources. Can be closed.
Daddy, look.
Two.
Oh,
Almost
so
closed.
Does it not turn on? The battery's dead, maybe?
look.
It turns on.
Want
but
to
it
show
turns back
you
off.
that
Yeah, that's so then the battery.
We extracted 1D spectrum with S-copy method. Next, we will be doing calibration with standard stars. But before I do that, I have to use the standard star frames and process them through all of these steps
Wait.
Yeah,
and
for the charges.
first, which I will do behind the scenes, since it's the same steps. I will not put a video about it, just exactly the same steps. And then we also have to remove manually, wait, I have to put it in the orange because it's
Did you guys get it?
will be working on it. And then we also have to do another step discarding some noisy region, discarding, working more on the residual lines, etc., etc. Okay. This. This one. Okay. And then we did the IRAF acknowledgement. I updated the provision law. This is done. I'll do it behind the scene. I already talked about this in the previous tutorials. The next step is flux calibration. This is standard star. How did it feel? Would it feel okay? So I will do this on my own, but thank you very much for joining me today and for your patience. I will stop sharing and wish you a nice midsummer holiday, and I will stop recording.